In this video, we're going to learn how to do least squares regression analysis. The problem we're going to use to illustrate is the weight of a car versus miles per gallon. So here I have a table that has 11 different car makes and models, corresponding weights, and corresponding miles per gallon. Weight will be the explanatory variable, and miles per gallon will be the response variable. Question 1, or question A, asks us to draw a scatter diagram. And so what we're going to do is we're going to highlight, including the titles, all the data. And we're going to come over here, we're going to hit Insert, we're going to hit this icon right here that looks like a bunch of dots. We're going to click it, we're going to click Scatter, and what it does is it plots the 11 ordered pair of points. You can go to this Add Chart element if you like, click the arrow, hit Trend Line, hit Linear, and you can see that it looks like we have a negative linear relationship. Part B asks, is there a linear relationship? And so what we have to do is use the correlation coefficient and check it against the critical linear correlation coefficient, which happens to be 0.602 for 11 data points. Now, we're really concerned or really interested in the magnitude. Since this is negative and it will be negative, I'm going to hit absolute value, which is ABS, and I'm going to come in here and I'm going to put correlation, and it's going to ask for array 1 and array 2. So we're just going to use the numbers. X will be array 1. We'll put a comma. Array 2 is miles per gallon. And I'm going to need to have an extra parentheses here. And I'm going to round that to like 3 digits to the right. And you see the correlation is 0.96, and the critical correlation is 0.602. And because this is, 0.602, because the correlation of the points is greater than the critical correlation, we do indeed have a negative linear relationship. Part C asks us to find the least squares regression line, treating weight as the explanatory variable and miles per gallon as the response variable. So what we need to do is we need to calculate the slope. So we hit slope. Now notice here it says known y's and known x's. So basically it's looking for all the y's, comma, all the x's. Okay? We expect a negative number because it's negative, a negative linear relationship. And we get this number right here. And again, we will go to 4 significant digits, and that will be our slope. Our intercept will also ask for known y's and x's, and so we will hit all the y's, comma, all the x's. Okay? And so basically, our intercept is 42.91. And if you were to extrapolate this line, that looks like it would cross the y-axis at about 42. So our equation, which is y equals mx plus b, where m is slope, b is y-intercept, y is equal to minus 0.0069 times the slope, times x plus 42.91. That is our equation of the line where x is the weight of the car, y is the miles per gallon. Okay? Part D, if a Buick Regal weighs 3,600 pounds, using the equation from Part C, which is this, what would you predict the miles per gallon for this car? So what we're going to do is we're going to use the equation 0 minus 0.0069 times, we're going to put in 3,600 for the weight, since x is the weight, plus 42.91. Okay, we get 18 miles per gallon. Okay. So one check you can make is you can come over here to about 3,600 and just sort of run up to the line and see you're at 18 miles per gallon. That concludes this video.